Okay, so the first thing we have to do is we have to make sure that to use any of the three theorems, we have to show that this function f is continuous. So what can we say? We're going to say that f prime exists for whatever x is taken, for x between, looks like negative, let's just say for x. Let's just say for all x. Therefore, f is differentiable. And that implies that f is continuous. Because we need both. We need the continuous for everything. Okay? Okay, well, let's do these. Okay, so what's this? To find the max and min, you're like, bam, that's the EBT. Ooh, you're like an output equals a number. That's the IVT. And this is saying that you've got a horizontal tangent. That means you're saying the derivative is 0. So this is the MVT. Okay, let's do our proofs. Okay, so 1. So we know that f is continuous on -5 to 5. We already proved that. Okay, so how are we going to find the x? So the extreme values, where do they happen at? Occur at x equals -5, or x equals 5, or at x where f prime of x equals 0, which is at x equals 2 and -2. Those are critical points. Okay, so we're going to make a table. Now, since we're going to go backwards because this is f prime, we need a starting value, which is why they give me this. So I'm going to put that in my table as well. Okay, so let's see. We've got x, f of x. We know we're going to go from -5 to, oops. Get the eraser. To 5. We know we need the -2 and 2 in there. And we actually have to put 0 in there because I'm going to put, this is like our starting value. Okay, and so we know that that's pi. And since we have a graph of the derivative, we know we're going to use area. And this is like our starting value. So let's go back up to the graph. And let's kind of use, this is our starting value. And this way we're going forwards. And this way we're going backwards. And we're going from 5 to -5. And let's get all the areas. Okay, so this is 1, 2, 3, 1, 2, 3. So this is 9/2 or 4.5. This has a radius of 2. So 2 squared pi over 4 is pi. So each of these has a pi. And this is 1, 2, 3 by 1. So this has an area of 1.5. Okay, now we just have to add up the areas. We have to be careful because this is going forwards. We're going forwards, below is negative, above is positive. And it's the reverse the other way. Okay, so let's start at 0. So if we're going to 2, we're going to do the starting value pi minus pi, which is 0. And then we're going to go 0 plus 4.5, which is 4.5. Now we're going to go backwards. And so we're going to have pi minus negative pi. So really we're adding. This is 2 pi. And then we have 2 pi minus 1.5. So now let's look at our values. Which one's the biggest? This is the biggest. So the maximum value is 2 pi. And the minimum value, this is less than 2 pi but positive. This is less than 2 pi, is 0. That's my dog. Okay, let's look at 2. Okay, so they gave us the interval. So we're going to tell the reader, oh, so let's do by the EBT, by the EBT for this one. Okay, let's see 2. Okay, so we're going to say f of negative 2. Well, we already calculated that. F of negative 2 is 2 pi, and f of 2 is 0. And they want us to see if we hit 6. So we're going to say 6 is bigger than 0 and less than 2 pi. So by the intermediate value theorem, there is some x on the open interval negative 2 to 2, where f of x is equal to 6. Okay. All right, let's see. So the MBT says the AROC is equal to the derivative at some place. So we got to calculate the AROC. So we are going to do, and we need to say f is continuous. For the MBT, we need f is continuous and differentiable. We need both of those. Okay, so we need to do the AROC first. So we need g of 2, which is 2 times f of 2, which is 0, so that's 0. And g of 0 is 0 times f of 0, which is 0. So we've got g of 2 minus g of 0 over 2 minus 0 is 0. Let's see. By the, you know what? Let's see if I can. I'm going to put up here. Let's go. By the MBT, there is some C on 0, 2, where G prime of C equals 0. Therefore, G has a horizontal tangent at x equals C. Woof, that's a tough one.